Yes, there are already 100 videos on YouTube which teach file compression. Why should you watch this video? Because we are not going to use any library. We are going to build everything from 0 to 1. But the problem is I haven't did this before and I don't know how to build Huffman tree. And also I have to figure out how I can generate codes from it. So I guess before building the project I have to do some research. I mean, we have to do some research. So I think it's going to be exciting. But there are a lot of things I'm going to learn by building this project, which will be used in industry level huge projects and which you are going to learn as well if you build it. So I think it's a win-win. So let's get started. Building like at least 10 videos. I've discovered that uploading long hours videos like 2 to 4 hours videos uh, like directly is not good because a lot of people often lose their motivation while watching the video. So what I'm thinking now is uploading at least half an hour parts of the whole project. So there will be parts like an episode, okay, like episodes of series where I'll uploading each part of the project one time. So and in the end as well, I'm going to combine them all and upload a single video as well. Okay, for the people who want to watch single long form video, which can prefer to that, and for the people who like to watch episodes, will refer to it. Okay, so yeah, let's get started. I have built this graph, file compression and decompressor. So the name is going to be JPAG. And the first thing which we have to do is, I guess, yeah, the first thing is GUI. I have to build the GUI. I have not made it too detailed because we don't know what we'll need later. So yeah, and here after that we have to get the file path, read file data, get frequency, Huffman tree, and so on and so forth. So one of the hard parts is understanding this one, Huffman tree, and generating codes. Like otherwise other things are easy, I guess. Let's go. Okay, let's get started with the GUI. Let's do it in the main file only. At the top, what we are going to do is I'm going to import tk enter first. So import tk enter as tk, and we'll import other things as we need them. So let's just use that first. I'm going to create here a class GUI, and let's create initialize. Okay, now let's do one thing here. Let's just remove it. Let's create object UI. Okay, and we are going to pass here one thing, that is it's going to receive root. Okay, so for those of you who haven't used tkinter, I would suggest that go first, learn it, and then watch this video, because I'm not explaining everything that I'm going to use in this video. Okay, the thing that I'm going to explain is the project itself. Like this project is about compression and decompression. So I'm going to teach only that, like what is Huffman tree, how to build it, and I'm going to do that well. Okay, and in detail. I'm going to explain everything in detail. Okay, so here let's pass the root now. Okay, um, the reason I don't get root is here I have not tk. Now there you go, and in the end we have to use root dot main loop, something like this. Okay, now we have got here root. So the first thing is I'm going to put that into shell. So cell.root will be equal to root. Okay, now the next thing is let's give a title. Okay, cell.title. So I'm not good with giving titles and all that. So let's just write gpck, and also geometry. Okay, sorry. And here let's give it 500 x 400. I guess this is going to be enough. Let's just check it out. I'm using init. Okay, so in order to use init, first you have to go to folder and do uv init, and then you can do this. And if you want to add packages, which I don't think you'll need, but if you want, you can do that by uv add. Okay, and the name of the package is it. Okay, now the thing is uv main.py. Let's see if we get the window or not. I've gotten an error. Oh yeah, my mistake. Here I just forgot to add root, because we are going to add the title on the root on the window itself, right? So that's why. Now as you can see, I've got the window and it's proper. I think it's good enough big. Yeah, that's what we need. Now the next thing which we want is a button, a label. Okay, not a button but a label. Self.label will be equal to tk.label, and where we want to apply this, on the root, and the text will be at say select a file, I guess. Okay, and then I have to do one thing, that is pack the label, otherwise I won't be able to see it. Okay, on the window. So pack, and let's give pad y 15, I guess. And after that, I have to create a button self dot, okay, sorry, select file, and tk dot button, and it's going to be on the root. Text is going to be browse file, and next thing is command is going to be self dot select file. Okay, now let me just create some functions here before jumping into creating the buttons. Just a second here. Okay, the first function we are going to need is select file. Here we'll put self, and let's just pass for now. And again one more function, that is compress file, use self, and again then pass here. After that, def decompress file self. Okay, sorry. And then here again I'm going to use pass, and the last function is going to be def Huffman tree. Okay, and this is also good. We are going to show visualize Huffman tree. So yeah, it's something which you should learn because it's good. It helps to understand how like visual Huffman tree will look. So it's good. Okay, now these are the four functions, and we are going to need other two functions which we will create later. Okay, but now for now it's okay. Self dot select button dot pad, and let's use pad y of 10. Okay, now I'm going to duplicate this like this for 3 times. Compress, decompress, and yeah, one more time. Okay, now here let's just select every select over here like this, and make it compress. Okay, now here also I'm going to change this to compress, and let's do that here as well. Here we'll do decompress, obviously. Decompress. Okay, let's do here decompress, and the last one is going to be show Huffman tree. Okay, now here I'm going to write. Okay, there should not be file here actually. Okay, but let's go. Here I have to write show um, Huffman tree. Okay, and in the end I'll need one more label, so let's just, I'm going to copy this and paste it right here. Okay, let's just change this one to status. Okay, and there's nothing going to be inside text because we'll add as it says its status. So whenever we'll compress or decompress a file, then we'll show the status here. Otherwise there would be nothing here. Okay, now the thing is, let's check whether it's looking good or not. Yeah, as you can see, it's looking good. Okay, it's readable, at least to me, and I can't say about you, but let me just guide you. It's select file, browse button, compress, decompress, show half minute read. That's what it says. Okay, now let's go to the top, and here we'll need one more thing, that is from tk enter, sorry, uh, import file dialog, and one more thing, that is message box. Here we'll first thing we'll check, no, not check, let's just, okay, now file, when we'll select file, we are going to use it inside or compress. So I think it's something which we have to make public, and by public I mean I have to put that in self. Okay, self dot selected file. Okay, when it's something which is common throughout all which is you're going to use in every function, then it's better to make it public. Okay, in public I mean this. Okay, it's just my way of saying it. Selected file, and it's going to be equal to, for now it's going to be none, obviously. And I think we are going to need one more thing here. Okay, I don't know whether I should put it now or later. Let's do it later as well, as we'll need it. Okay, now here self dot selected file will be equal to file dialog dot ask open file name. Yeah, yeah, this is the one. Okay, if um, self dot select selected file. Okay, then let's just show the file name label dot config, and the text will be um, selected file, and then self. Okay, it's like I can't directly show it. Let's do one thing. um, File path. Now we can't show the full path here. Okay, um not file path, actually file name. Okay, because file path is too big to show here, that's why we are going to show just the name. Okay, and that's why I'm going to use here. Okay, from path lib import path. Okay, let's go down, and that's the reason I'm going to use path here. And let's just put self dot selected file here, and just so that we can do something like file name dot, okay, it's going to be file path, not name, actually, sorry. Okay, um, file path dot name, so we'll just have the name here. Okay, after that, if if there is nothing selected, then I'm going to show error by message box, not error, warning, I guess. um, File not found, no file selected. I'm not good with this. Okay, so I guess you have to chat GPT what to write, but yeah. Okay, just a second. So let's try to select file. Let me just select this one, open. As you can see, we are getting the name of it, and if I cancel it, okay, no file selected, file not found. Yeah, good. So it's good. Okay, now we have covered this one. Yeah. Now the next thing is compressing. Okay. So here I'm going to check if not selected file, then show and no message box dot show error and not found, no file selected. Yeah, otherwise if the file is there we are going to use threading. Okay, now why the fuck we are going to use threading, I'll tell you just a second. Okay, now the reason we are using threading is because we have GUI here which will be running behind the scenes when the compression will happen. Okay, now let me just let's just go to here. uh, okay, now let me show you in this corner. Now here we have GUI. Okay, we have GUI here. Okay, and now simultaneously we are also going to run the compression or maybe the decompression as well. Okay, okay, now okay, let me just, yeah, so simultaneously we are going to run these both things. Okay, like when we'll open GUI, we'll click on the compression button and the compression will happen, right? But the problem here is that we have main thread. Okay, let me just show you. We have just one thread which is main thread. Now first will be on GUI, so main thread will be here. After that, when you click on compression, main thread will go to doing the compression work. And when you will when main thread doing when main thread is doing the compression work, and that at that same time when you will try to interact with GUI, it will not work. Okay, so to solve that problem, what we are going to do is we are going to keep the main thread to do the GUI work, and we are going to create second thread and give it to work of compression and decompression. So main thread will work on GUI and second thread will work on compression, so nothing will lag. Okay, that's why we are going to do this. I hope you understood what I want to say. Now let's just use threading here. Threading dot thread, and the thing is we're going to use target self dot. Okay, that's what I said. That's why I said that we will need two more functions. Def um, compress compressor worker compress worker, I guess. Self. Okay, self. Let's just pass for now. Okay. Yeah, that's it. And then we'll do something like thread dot start. Okay. Yeah, I think this is it. Okay, after that we have to now it's time to do the compression work itself. Okay, so now what we have to do here is we got the file path. Now we have to do read file data, so let's do that. Okay, now read file data, where we'll do that, we'll do that here, right? So input file will be equal to path and self dot selected file. Now we have to, I'm going to build a folder here named core. Okay, but for small projects I build core and put all the files in here. For huge projects we'll do that differently. Okay, let's build a file R and W, which is read and write. Okay, okay, I thought no, I don't know whether I'm hallucinating or not. Okay, let's fuck up. Okay, what I'm saying is let's build a function. I think we'll need here as well that from file path, sorry, from path lib import. Okay, import path Okay, now let's create a function called read binary data. Okay, it will receive file path. Okay, um, let's do one thing. Okay, doesn't matter. Uh, um, Path will be equal to something like file path. Okay, and then we'll check if not path dot exist. Okay, um, what can we do? Raise. Okay, okay. So what I'm going to do here is raise file not found error. Okay, and file doesn't exist. File doesn't exist. Okay, after that, I think this is enough. Okay, we have to also check if it's file or not. Okay, if not, path dot is file. Okay, and in that case, raise. I guess we raise value error. Okay, value error. It's not a file. And after that, if everything is correct, I have to open the file. So I have to give path. We are going to read it as binary, so RB as file here. Yeah, so we are going to read it as file. Okay, after that in data I have to do file dot read something like this, and in the end I have to return that data. Okay, now here I can't print the whole data. Okay, let me just show you why. Not show you, let me just tell you why. But before that, let's just import this file. Okay, from core dot file. Now here file core dot file r and w, import read binary data. Now let's go down. Here we receive raw data. Okay, from read binary data, and there will send string of input file. Perfect. Now I'm going to print the first 10 characters or 20 characters of it, because as I said, I can't print the whole raw data because it's going to be too much. Okay, let's just run. Now the thing is, okay, let's just do one thing. Let me just stop this video for now. Yeah, so I have got this textbook.txt file which has this much long data, as you can see. Okay, it's to use, so that's why we are not printing here. Okay, now what I'm gonna do is I don't want to select the file every time and um, click the compress button every time, so that's why I'm fucking not being able to clear it. Okay, it's okay, let me just remove that terminal. Yeah, here. Yeah, so what I'm gonna do here, that's why let's just do one thing, self dot selected file and raw, and let me just, why I'm using R instead of F, because it's a raw string, so that's why. Okay, yeah, it's perfect. So it's ignoring all these values in blue, which it would have not ignored if I would have used the F string. Okay, now yeah, now I don't have to select the file every time. So uv run, not iv, uv run main.py. Yeah, let's hit compress. As you can see, we have got the first 20 characters. and binary, as you can see here. Okay, so now our first task is done. Not first, but yeah, we can call it first here. Okay, in this function at least. Now we have to get the frequency, which is quite easy. Let's do that. So to I'm going to create a file called Huffman.py. Now here we'll do everything regarding generating codes and building tree and all that. Okay. Now the first thing is we'll need from collections import counter. Okay. Now def build Huffman frequency, and it's going to get raw data. Okay, after that we have to check. If not, uh, is instance raw data is byte, then raise type error, which is data should be in bytes, I guess. After that, if it's raw bytes, then frequency. Okay, build frequency table. Okay, frequency table, and here frequency table will be equal to counter, and in that I have to put, we don't have to do anything. Okay, we just have to put raw byte inside counter, and it will create the table for me, but it won't be, it will be an object, counter object. Okay, now we have to convert that into dictionary. So how we are going to do that? We can just put dictionary over here. Okay, and then return it directly like this, or you can do it over here as well, but I prefer it over there. Now it's done. Let's call it over here. Okay, from core.huffman import build frequency table. Let's go down. Okay, let's just remove this frequency table. Okay, now what I have to do here is build frequency table and pass the raw data. Okay, now let's print it. Let's check if it's working or not. Okay, I guess. Okay, so let's check if it's working or not. Hit compress, and as you can see, we've got the uh, frequency table. So let me explain what it says. So on the left you will see the key values, the keys, which are bytes. Okay, which are bytes in integer decimal, and on the right is the frequency, means how much time they appeared in that file. So it's every, I think it's 10,000. Yeah, it's 10,000 for every byte, and yeah, that's what it is. Okay, now the next thing that we have to do is we have built frequency table. um, Now we have to generate the Huffman tree. Let's do that. As I said, we have to do that over here as well. All the Huffman things we are going to do here. Okay, let's do build Huffman tree, and what we are going to get here is frequency table. Now again we have to check, if not is instance frequency table dictionary, then you might have got to know that we raise type error for these kind of things. And what is going to be frequency. Okay, frequency table should be dictionary. Okay, and if it's dictionary, then okay, if it's dictionary, then I think as much as I remember from the research as that is that I have to create a heap list and a count. I need heap list and a count here. Okay, which will be 0 for now, and then we have to use for loop for byte value, byte, and the frequency of it in frequency table dot items. Okay, and then what we have to do is uh, okay, but before that we have to create node of we'll be creating a node object. So for that I am going to create a class Huffman node and def init. So it's going to receive four things. Let me show you what. So first will be byte value, next will be frequency, and then it will be left, so it will be left node, so which will be none by default, a right node which will also be none by default, and then over here I'm just going to put them in self dot byte value will be equal to byte value, and let's just duplicate this frequency left and right. Yeah, it's done. Okay, after now here I'm going to create node. So I have to build the node like this, half a node, and right here byte and then the frequency. Okay, now we have got the node. Now we have to push this into the heap. So how we are going to do that? For that we'll need heap queue. So what heap queue does is it reorders everything from in ascending order. Okay, from like low number to high number. Import um, heap queue. Yeah, that's how we import it. Okay, now here heap queue dot um, heap push, I guess. Yeah, heap push, and then here I have to pass heap and the three values, which is going to be frequency. So we'll be reordering them on the basis of frequency, and then counter. Then the next thing we'll reorder them on this counter and the node then. Okay, and I'm going to increase counter after that. So counter by 1, so it will be 1 2 3 4 5 like this. Okay, after that I have to check. Now if our file just holds one repetitive digit, or let's say alphabet, which is A, then the node, there will be just one node. Okay, and in that case what we have to do is we have to check if length of uh, heap is equal to 1. In that case return the heap. So as you can see, there will be if only one thing is there, item is there inside the heap, then the length of list will be 1, and inside that one there will be three items, three values, that is frequency, counter, and the node, and we need the counter. So first we'll be taking the first item from the list, and then inside that we'll taking the second value, which is the node. Okay, so we'll be returning that. And after that, if length of heap is more than 1, then we are going to use while loop. While length of heap is greater than 1, okay, and my god, okay, it's okay. If length of heap is greater than 1, in that case what I'm going to do is, okay, um, Okay, we are going to take, yeah, so now I remember. Now we'll need the left, so we'll take the smallest frequency first and we'll name it left frequency, and then the counter which we have no use of, that's why we are using underscore, and then left node. Okay, now let me explain this to you just a second. Now here we'll use heap pop. Okay, so not like this, heap q dot heap pop. Okay, and then pass the heap list. Now how this works is, let me do this here. Let's say we have these values. Okay, 1 2 3 4 5. Now when I do heap pop with heap q, and left frequency means it will take one out first. Okay, like this. So here we'll have one, and now let me just show you. In the right frequency, we'll have two. So we have took out the one, and now there is no one inside the list, so one is like gone. Now it's from 2 to 5, and then we'll take out the 2 as well, like this. Okay, now there is from now it's from 3 to 5, like that. So left frequency is this one, and right frequency is this two. So here we got that. After that we have to create node, merge them, merged frequency, and it will be left frequency plus right frequency. Okay, after that I have to create the node. Okay, not like this, merged node, and here will node, and there will be no byte value because it's a merged frequency, right? So it will be none. Frequency will be the merged frequency, as you might have guessed. And now we'll have left node. That's why we put default as none before. Okay, now here we'll have the value. Left node will be in left node, and then right node will be right node, like this. After this, what we have to do is we have to push them inside heap using heap push, then pass the heap, and the first thing is merged frequency, counter, and last thing is merged node, like this. Increase the counter plus equal to 1, and in the end return the heap as I told you, like first 0 and then 2. Okay, now let's just use it here. Build Huffman tree. Let's go down. Okay, now as I told you, we will need to put Huffman tree in self as well, because we are going to use that. Now what is this? Okay, not like this. I need to change the name of this function. Yeah. Now here we'll also make Huffman tree public, because we'll need to use that across multiple functions. So that's why. Okay, now build tree. Okay, and we have to put the frequency table. Now let me just try to print. Let's just check. We'll see nothing, we'll see an object. Okay, and you don't have to worry about that. I'm going to show what we'll get there as well, and how we are gonna get how I'm going to show you that as well. Okay, let me just hit compress. Okay, I've got an error. Heap pop, heap q dot heap pop heap. Yeah, actually there is a spelling mistake. Okay, now it's perfect. Let's run it. As you can see, we have got the Huffman node object, and this is what we've got. Now in order to get what we have inside it, what we have to do is we have to create here this. Okay, and here what we have to do, we have to return something like this. Okay, byte value If you do this, you'll see what we have there. Okay, just drag it like this and change these to frequency, left, and right. Right. Okay, now here after eq, left and right. Now keep in mind, before we did that, we got an object. Okay, now we'll have this over here in the terminal. Okay, now when we try to print something in class and we have this repr function or method, I'd say we call it method. Okay, yeah, so we'll get this. Okay, let's just save it and let's just check if we get this or not. Let's hit compress. Now as you can see, we've got that. Okay, now none frequency, none right. Now there might be some problem here, or okay, let me just try to print it. I'm going to enter this over here. Okay, byte value. Okay, so I've got that. I think I'm wrong here, so I'm going to do one thing, that is, okay, here I'm going to change this byte value, and just a second, not outside it too, inside it. Okay, now here frequency will be self dot frequency, and now I'm just going to wrap it with parenthesis, and I'm going to put Huffman node outside it. Now we'll see if it's working or not. Okay, let's just do compress. Now as you can see, we have got now, and frequency is something like 50,000. Okay, now if I want, I think I can now do this as well. Let's check. Let's print left node. Okay, self dot left. Now let's do check it. Now let's just check it. It compress. Yeah, as you can see, we've got left node as well, so it's working. Right, it's working. So now we have successfully achieved or did um, we have successfully did the Huffman tree code as well, so it's good. Okay, now the only thing is here it's not tree. Okay, it's a root, so I have to change that. I have to do root here. Okay, yeah, that's it. So I guess in this video I'm just going to teach this much, and there will be next episode of this project, where we'll cover the rest of the things which are still pending. And yeah, that's it. Thank you.